Hi, hello everyone. So welcome to Venki's Emerging Edge YouTube channel. So this is Venkatesh. Today we will talk about Cryptarithmetic based on your comments. So first of all, what is constraint propagation? Because of the constraint propagation is one of the technique in artificial intelligence. Why we are using of artificial intelligence? The artificial intelligence covers a variety of methods and techniques to solve the complex problems. So the constraint propagation also to solve the problems. Okay, so where we are using a constraint propagation? So generally constraint propagation are used in a different areas. One is scheduling. Next one is a planning. Finally, resource allocation. The three different areas we are mainly applying of constraint propagation. The name itself constraint, that means the rules based on condition we will propagate to reduce the solution. So how is possible? Yes, it is possible. So here we are mainly focused about constraint propagation. Okay. So constraint propagation is a fundamental concept in CSP. We know that up to now we discussed constraint propagation, but here CSP. CSP means constraint satisfaction problem. Is it clear? So today we will discuss about Cryptarithmetic. It is one of the example in a CSP, constraint satisfaction problem. Okay. Now what is constraint propagation? What is constraint propagation? So the constraint propagation narrow down the possible values for a variables in a constraint satisfaction problem by applying the rules to help them solve the problem. For specific domain. So once more, the constraint satisfaction problem. So constraint satisfaction problem, it is one of the fundamental problem in a constraint propagation. So in which the constraint propagation narrow down the possible values for a variables in a CSP by applying the rules to solve the problem for a specific domain. So here we are mainly focused about variables, rules and domain. These three keywords are mainly plays the key role in a constraint satisfaction problem. Is it clear? So that's why here what I am saying, the constraint satisfaction problem, they follow the some key concepts. They are mainly variables, domain and constraints or rules. That means the CSP involving variables need to assign the values from given domain. So what are the possible values that can be assigned which satisfy the constraints? That means rules that defined. Is it clear? Finally what I am saying, the constraint satisfaction problem involves the variable that might be assigned values from a given domain while satisfy the constraints. Is it clear? This is a definition of a CS, Constraint Satisfaction Problem. Yeah? Okay. Now here we are mainly follow some steps in a constraint satisfaction problem, in which we are mainly focus about three different types of steps. One is initialization. The second one is propagation. The third one is iteration. By using of the three steps, we follow the constraint propagation, like a constraint satisfaction problem. Is it clear? Propagation. So what is meaning of initialization? Initialization means initially we start with some domain of variables. Domains of variables. We start with initialize, the name itself initialized. We start with a domain of variables. For example, like a is equal to 1, like a b is equal to, like that we are initialize some variables for domain of variables. The next one is a propagation. So here what is propagation means? Apply some constraints. To reduce the domain. So here first one initialize the variables, next one apply the constraints. What are the constraints are given? Those constraints are applying for to reduce the domain. The next one finally iteration. Iteration means the name is a repeated. Repeat the propagation. What do you mean of propagation? Initialization, applying. Initialization, applying up to. It's continue process up to finally get a solution. So these three steps are mainly applied in a constraint satisfaction problem. Is it clear? Now these are mainly applied in a different types of example problems. So generally we are showing different textbooks, whatever it may be. Those are called a graph coloring. And one more, Cryptarithmetic. So here this video is mainly concentrated on how can you apply Cryptarithmetic in a constraint satisfaction problem. Is it clear? Okay. Now we discuss about example of Cryptarithmetic puzzle. So here the main goal is to find the correct digit assignment such that a given arithmetic equation. It's a goal. What is the goal? Find the correct digit assigned such that a given arithmetic equation. For example, ONE1 equals to TOO2. We know the general 1 plus 1 equal 2. But here ONE1 equal to. That means which digit is assigned to the 0, that is same digit is assigned to the 0, O and O. Which digit is assigned to n, that is also same digit to n. Which digit is assigned to e, the same digit. Finally, here both are combined. 1 plus 1 is it. Finally, you get a TWO. That is a, so that's why find the correct digit to the assigned such that a given arithmetic equation. That is a main Cryptarithmetic puzzle equation example. Is it clear? So how is possible? Yes, it is a possible. For example. So here, for example, ONE T, W, O. For example, E can assign with a 1. So E equal to 1. Then E plus E. 1 plus 1, 2. So O automatically assign the 2. So here also O can automatically assign the 2. 2. So then T get a 4 only. Check it. Next one. N. So O, 2. N we can assign the 3. For example. So 3, 3. So automatically W can assign the 6. So that means 2, 3, 1, 2, 3, 1 equal to 4, 6, 2. So this is a O is a 2. O is a 2. Here O is a 2. So this is a to finally to reach the goal of digit assignment. This is a arithmetic equation. This is a cryptarithmetic puzzle. Is it clear? Now like that we will discuss about one of the most famous example. Send a more, finally get a money. So here each letter must be assigned a unique digit and sum must be whole true numerically. For example, to solve this problem, so we can applying of CSP. First one, CSP, what are the main components are? Main keywords. What is the first one is a variable. The second one is a domain. The next one is a constraint. First one variable. Variable means here each and every letter. What are the different letters? S, E, N, D, M, O, R. E is already repeated. M is already repeated. N is already repeated. E and Y. These are main variables. Variable nothing but these are letters. Next, domain. What is the domain? Here we can use the digits of 0 to 9 only. 0 to 9 only. This one. Next, one more is S and M cannot be 0. That is the most significant MSB. Most significant bits of S and M is cannot be 0. S and M cannot be 0. What are the constraints? So here what are the constraints we will follow it to solve the problem. What is the constraint? First one is no two letters have same value. First one. Okay. Next one is sum of the digits must be same as shown towards. Next, there should only one carry forward. Yes, it's possible only. Why? Because of maximum 9 plus 9, maybe 18. Only one carried forward only. Next one is a left side is not 0. That's nothing but a MSB. In which MSB means left side. This is a most, this one M. So these are constraints. Is it clear? So now we solve this problem. So again, write like this way. Can easily identify. What the values are given? S, E, N, D, M, O, R, E, M, O, N, E, Y. First of all, we are mainly focused about which value is repeated. So here we can identify the M 1, 2 times repeated. But we know condition S and MR cannot be 0. Yes or no? So cannot be 0 means here may not be 0. So first of all we put a M equal to 1. Here put a 1, 1. Is it clear? So here 1. So we are adding the S S value, then get a only carry forward. So 1, 0 to 9, which value is suitable? 9 only, then only get a carry forward. So S equal to 9. So 9 plus 1, 10, 1. So automatically O getting a 0. So 0, O getting the 0. So O nothing but a 0. Is it clear? Is it clear? First, again one more. First, as well condition S and M is cannot be 0. So that's why M is put like a 1. Here also put a 1. So how to get a 1? M plus S that carried forward. So that's why, so 0 to 9, we can add the 2, only 3. There is no carry. 4, 5, 6, 7, 8, 9. 9 plus 1, 10, we get a carry. So that's why S put a 9. So 9 plus 1, 0. 9 plus 1, 10. So 1, again 0. So O is a preferred like a 0 only. Okay. Now, next, what is repeated value? E. E is repeated. For example, he is put it like a 5. For example, in case of it is not satisfied, go for back. It's a backtracking process. For example, 5. So automatically get a 5. So which value can be added? Which value can be added? We get a some carrying. For example, 5, we carry plus 5 plus 5, 10, 0, but 0 is already O assigned. 5 plus 6, 11, so 1 is already, so 5 plus 7. So E is equal to 5, D is equal to 7. Is it clear? Okay. So 7 plus 5, 12. So Y is a like a 2. So carrying 1. 1. So which value can be added to R, then getting the 5? That is a 1. But here again we are adding the carry and R value and N value. Okay. Next one. Here, if for example here N value is put like already 5 is over. So next we 6, 7 is over, put a 6. 6 plus 1, 7. Then we are adding we would finally get a 5 only. So 7 finally get a carrying 5. So which value is suitable? That's why we are adding 5. 7 plus 8, 15, 5, 1 carried. Is it clear? So here 6, here also 6. Next, E is already decided, E is 5. So N is 6, R is 8, N is already 6. So E is already 5, 5. 5 plus 0, 5, 5 plus 1, 6. So this is, so finally, this is your solution. Is it clear? Again, I will explain. First of all, M and S cannot be 0. That's why I put a 1. M is put a 1. So automatically M is replaced with a 1. So which value is suitable for to get a carry? 9 only. So S is a 9. 9 plus 1. So automatically O become a 0. So O is a 0. So O can be replaced with a 0. Next, we start with a next. Which one is repeated? E value repeated 3 times. So coming to E. So E, which value? E taking the 5 only. So generally we check it to 5, started with the 5. So which value can be 5 plus 5, 10, then getting the 0. Already O is 0, so that's not suitable. 6, 11. So 1 is already M, it is not suitable. So that's why given 7. 5 plus 7, 12, 2, 1 carry. Is it clear? Already 5 is over, 7 is over, but 6 is pending. So that's why N plays with a 6. 6 plus 1, 7. So but here getting the 5. How is possible? Adding 8 only. So 8. 15. 5. E can be replaced with a 5. Again carrying. So 5 and carry 1. So which one is suitable? 6. So then O is already replaced with a 0. 6 plus 0, 6. So this is, so finally this is your solution. Is it clear? So thank you for watching Venki's Emerging Edge. If you have any doubts, please comment in this video. Thank you.